Spring break should be great.
Spring break should be like 6 months.
Yeah, we only get one break there.
Okay, so we have a curve, y is equal to x squared plus 2. Let's say I want to find the area under the curve. This is a pretty important concept, believe it or not. The problem here is that this is a curve, and I don't really have a good way to find the exact area under the curve, at least not yet. So there are some ways to estimate the area under the curve, and one of those is Riemann sums, which we are looking at today. And Riemann sums is really pretty straightforward. All we are doing is finding the area of rectangles. So if I were to divide this up into 4 rectangles here, it would look something like this. This approximation, however, is not a very good approximation. It's going to be an underestimation because I'm left with this area in red here that is not accounted for by my approximation. This is called a left Riemann sum because the left side of my rectangle here, 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 and here is on the curve. So this is a left Riemann sum. I could also look at a right Riemann sum. So a right Riemann sum in this case is going to be an overestimation because of the area in red here that is above the curve. And again, it's called a right Riemann sum because the right side of my rectangle here, 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 and here is on the curve. Okay, so these are not very good estimations because of all of this area that is not under the curve. So how could I make my estimation better?
Mix of both.
Okay, I think what you're saying is I could do maybe a midpoint estimation. That would be better, right? Because if I do a midpoint estimation, that is going to minimize the area that is not covered. So a midpoint estimation, I'm going to have some area under the curve that's not covered, but then also some over the curve, and those are going to kind of cancel each other out and give me a better estimation. So that's one way. What's another way I could have a better estimation? Okay, so what you're saying is to use the rectangles, but then subtract off that area that's not used. Okay, that would work. Another way, what if I added more rectangles? That would be better, right? If I'm using 4 rectangles, I've got a lot of area here that is not part of my area that I want. If I were to double the amount of rectangles to 8 or then 16, that would minimize the area and give me that is not used and give me a better estimation. Correct? Well, what about, and this is where we're going, right? Let's talk a little calculus. What about, wait for it, an infinite number of rectangles, right? That would give me an exact area. Oh, that sounds fun. That's what we're going to do later in the week, right? But for right now, we're going to look at Riemann sums. Okay, so let's go back to the notes here and look at some specific examples. All right, so here we go. The method of Riemann sums is used to estimate the area between a curve and the x-axis or between 2 curves by dividing the region into manageable rectangles. So example 1 says, calculate the area between this curve, f of x is equal to x squared plus 2, and the x-axis on the interval from 0 to 2. And we want to use a left Riemann sum with 4 equal subintervals. Okay, so there's a little shorthand way of writing this, I've got an LRAM that stands for left rectangular approximation method. And I've got a subscript of 4, meaning 4 equal subintervals. And so let me draw a picture here so that you can see it. So I'm going from 0 to 2. So that's going to be 1/2, and this will be 1.5. And this is a left Riemann sum, which means that the left side of my rectangle is on the curve. Okay, so it's going to look something like this. And so you can tell by looking at this that it's going to be an under approximation. And so these are really not hard, and I don't want you to get confused, but all we're doing here is finding the area of the rectangles. So the area of a rectangle is the length times the width. The width is going to be my x value. Since they are 4 equal and I'm going from 0 to 2, the width of each one of these will be 0.5. So I'm going to work this out kind of a long way just to show you. Okay. The width is 0.5. The height will be given by the left side of my rectangle, okay, which is my y value. So in this case, it would be f of 0. And then I'm going to find the area of my second rectangle. It goes from 1/2 to 1. So my width again is 0.5. And my height is going to be given by f of 0.5. And then I have f of 1. All of these have a width of 0.5. And then my last one, I have 0.5 times f of 1.5. And then if this is a left Riemann sum, I am not going to use my last my last x value here. Okay, because this is not part of the last rectangle if it's a left Riemann sum. Okay, so this line right here would not get you credit on the AP exam. Okay. The next step that I'm going to do would, however, I'm showing you this because these, I wanted to make sure that you have this in the notes so that you can see that these are the y values. Okay, so let's clean this up a little bit. I'm going to factor out a 0.5. All of my widths are 0.5. And then I need to find f of 0. So if I take 0 for x and plug it in, I get 0 plus 2. So my first y value here is going to be 2. And then I need to find f of 0.5. So I plug in 1/2. 1/2 squared is 1/4. Thank you very much. So I've got 1/4 plus 2, which is 2.25. And then if I plug in 1, I get 1 squared plus 2, which is 3. And then my last one here, I'm going to plug in 3/2. 3/2 squared is 9/4. And 9/4 is 2.25 plus 2. So my last value here is 4.25. Okay, so this line right here would give you credit on the AP exam. All right, and you should probably, unless you need to keep going, you probably need to stop here. All right, once you get to arithmetic on a free response question, stop. Okay, so that you don't make a careless mistake. I'm going to go ahead and give you the answer here, though. If you work that out, 2 plus 2.5 plus 3 plus 4.25, and then multiply by 1/2, you should get 5.75 for your estimation. And we also said by looking at our graph here that this is an under approximation. And this is how you justify it. You must have these two components. Okay. It's an under approximation because this is a left Riemann sum. It's an LRAM. And we say f of x is increasing. Because my function is increasing and this is a left Riemann sum, this will be an under approximation of what the actual area is. Okay. So part B here says calculate the area between this curve and the x-axis on the interval from 0 to 2. And we're going to use a right Riemann sum this time and still keep the 4 equal subintervals. So this is an RRAM. And let's draw it here. Again, we're going from 0 to 2. We need 4 rectangles, so we have 0.5 and 1.5. And this time, it's a right Riemann sum. So it will be an over approximation, and it's a right Riemann sum again because the right side of our rectangle is on the curve. So my width has not changed. It is still 0.5. What has changed is my y value. And if it's a left Riemann sum like we did on the first one, I'm not going to use the last one. If it's a right Riemann sum, I'm not going to use the first one because this first one is not part of the height of the rectangle that is on the curve. Instead, I'm going to use f of 0.5. And then I've got 0.5 times f of 1 plus 0.5 times f of 1.5 plus 0.5 times f of 2. Okay, and I am writing this out like this so that you have them in your notes, but you don't really need to do this. Okay, if you are working these out, you can just write the next line. So I'm going to factor out a 0.5. And then I'm going to write down these y values. And I can use the ones, I've already calculated those, right? F of 0.5 was 2.25. And f of 1 was 3. And f of 1.5 was 4.25. And then the last one here, if I take 2 and plug it in, I get 2 squared plus 2, which is 6. And again, if I add all those up and then multiply by 1/2, you should get 7.75 there. And I can see that this is an over approximation. And how would I justify it? It's an over approximation because it's an RRAM and what? F of x is increasing. Okay, please don't say it. Okay, you will lose points for the justification. We say the function is increasing. F of x is increasing. Okay, so that is my RRAM. So now we're going to look at one more example here using the same function, and this time do a midpoint Riemann sum, again with 4 equal subintervals. So this time I want an MRAM 4, and let's draw a nice little picture. Okay, I've got 0, 1, 2. This is 1/2, and this is 1.5. And so for the midpoint, it's kind of hard to draw on here, but again, the widths of my rectangle have not changed. So this is still going to be 0.5. What has changed are my heights, and instead of using the left side or the right side this time, hard to see on here, but we're using the midpoint. Okay, so the midpoint of 0 and 1/2 is 0.25. So I'm going to want f of 0.25 for my first rectangle. And then the midpoint of my next rectangle will be halfway between 1/2 and 1, which is f of 0.75. And then we've got f of 1.25. And my last one is going to be f of 1.75. And on this one, it's probably easiest to use a calculator. You can take those values and plug them in, or you can do this. You can use the table on your calculator. So let's take a look at that. If you take your calculator and you put the function into your calculator, x squared plus 2, and then I'm going to go to table set, which is second window. And I want to start my table. You can start it at 0. But the important thing is to change the table here by 0.25. So I'm going to put this change table at 0.25 and then look at the table. So I'm going to hit second graph. And then it gives me the values. So f of 0.25 is 2.0625. And then scrolling down to 0.75, I've got 2.5625. 1.25 is 3.5625. And then 1.75 is 5.0625. So I need to write those values down. So going back to my notes here, this is the line that will give me credits. I factor out the 0.5, and then I had 2.0625 and 2.5625 and 3.5625 and 5.0625. And go ahead and calculate that value for me for your approximation. And somebody want to help me out? What'd you get? 6.625. And does that make sense in the context of this problem? It should, right? Because my overestimation was 7.75 and my underestimation was 5.75. And so my midpoint should be in between those two values, and it is. And there is no under over on a midpoint. Okay, they're not going to ask you about that. They will ask you, or they might ask you about a left Riemann sum or a right Riemann sum, but not on a midpoint. They're not going to ask you whether it's an overestimation or underestimation. So let me pause there for just a second. Any questions on the first page there over anything that we have done so far? Anything that I can clarify for you? All right, why don't you turn the page here? And we're going to look at some unequal subintervals. Example 3 says the rate at which water is being pumped into a tank is given by the function RT. A table of selected values of RT for the time interval from 0 to 20 minutes is shown below. Approximate the amount of gallons that have been pumped into the tank using subintervals shown in the table with a right Riemann sum. Okay, so a couple of things that I wanted to note here. The first thing is this: the area under a velocity curve is the displacement. So when we find the area under a velocity curve, it gives us back the displacement. So here I have a rate. It's in gallons per minute. So this rate is like a velocity curve. So when I find a right Riemann sum, okay, they asked me to use this to find a right Riemann sum, and it's going to approximate the amount of gallons that have been pumped into the tank. Okay, so a right Riemann sum will approximate the number of gallons in the tank in this case. And they asked me to use the values that they gave me in the table. So again, I'm just finding the area of rectangles. I've got the rate on my y-axis and the time on my x-axis. So the width of my first rectangle, it goes from 0 to 4. So that is 4. However, I am not going to use 46 here. Why not? Because it's a right Riemann sum. And look back on the first page. If it's a right Riemann sum, we're going to ignore the first y value here. And so the height of my first rectangle would be 42. The width is 4, the height is 42. And so now I'm going to do the second rectangle. The second one goes from 4 to 9. So I have a width of 5, and my height in this case would be 33, or the length. My next rectangle goes from 9 to 17. So my width is going to be 8, and my height is 28. And my last one here, I've got a width of 3 and a height of 25. And I could leave this line right here and get credit. All right, however, I might need it later. So let's go ahead and just calculate that. And I will give you, it should be 632. And let's put some units on there. Again, if I find the area under the curve of a velocity, it's going to give me back displacement. And so specifically in this problem, if I find the rate of flow of the liquid, it's going to give me 632 gallons. Is this an under approximation or an over approximation? And how do you tell? Well, let's look at it for a second. Is my rate increasing or decreasing? It is decreasing because it is going down. So my function, if I were to sketch a really quick graph, it would do that, right? Because it's decreasing. And so now I'm going to draw in a right Riemann sum, which means the right side of the rectangles are on the curve. So it's going to look like that. Therefore, this has to be an under approximation. And my justification, because this is the right Riemann sum, it's an RM, and what? Not f of x, and r of t is decreasing. Okay, so example 4 here. Bob goes out for a drive with his dad, who's very strict about Bob's driving speed. Dad checks the speedometer every so often and records Bob's speed, shown in the chart below, using a midpoint Riemann sum with 3 equal subintervals. Estimate how far Bob drove during this trip. Okay, so we need an MRAM with 3 equal subintervals. And so this is really fairly straightforward once you identify what they are asking you. Okay, and so I don't want you to miss this. It's a midpoint Riemann sum with 3 equal subintervals. It goes from 0 to 30. And I have 3 equal subintervals, meaning the width of each rectangle is going to be 10, right? It goes from 0 to 30, and there are 3 of them. So here's the first one. Here's the second one. Here's the third one. All right, so the width of each rectangle is 10. And now I need to find the height. And so this is a midpoint Riemann sum, and don't let these other values confuse you. Halfway between 0 and 10 is 5. So I'm looking at this y value. So my first y value is going to be 3696. Okay, so my first rectangle, the height is 10. Excuse me, the width is 10, the height is 3696. And then my second rectangle also has a width of 10. And the height is going to be the midpoint of 10 and 20, which is 15. So it will be this value right here. So 3520. And my last one here, I'm going from 20 to 30. And so my midpoint is going to be at 25. So the height of my last rectangle would be 880. Okay, and let's put some units on there. This is measured in feet. And I would probably leave unsimplified unless I have to simplify. Okay, but it's perfectly fine to leave it like that. Putting units on there if they ask for it. Okay, so any questions on these 2 examples here that we have done? Let's look at one more AP style question. No calc allowed, so put those calculators away. And it says a car travels on a straight track during the time interval from 0 to 60. The velocity measured in feet per second and the acceleration is a measured in feet per second, and they're both continuous functions. The table above shows selected values of these functions. So part A says use a left Riemann sum with sub intervals indicated by the data in the table to find the displacement of the car. And so again, we are going to use a Riemann sum to find the displacement because the area under a velocity curve gives us displacement. And we are using an LRAM. There's no subscript because they are unequal subintervals. And my first rectangle will have a width of 15. It goes from 0 to 15. And my height would be the value on the left. Okay, so -20, meaning since this is a left Riemann sum, I'm not going to use the last value in the table. Okay, so I've got 15 times -20. And then just be careful on these, right? So that you don't make a careless mistake. The next rectangle goes from 15 to 25. So it's 10 times -30. And then 5 times -20. And then 30 to 35, the width is 5, and my height will be -14. And then from 35 to 50, so I've got 15 and -10. And make sure that you write the last one here, even though it's 0. We still need to write it so that the College Board people know that I'm calculating a left Riemann sum. And I am going to go ahead and find my answer here because I will need it on the next question. But oh, you can put those calculators away because this is non-calculator. What? So let's see, we got 15 times -20, it's -300. And that's -300, and this is -100. And let's see, that's -70, and -150, and 0. So let's see, that's -770 minus 150. So you should get -920 for the displacement. And let's talk just a second. What is displacement again? It's been a while since we've talked about some physics. Displacement is?
Distance traveled from the
Uh,
origin.
what if we don't start at the origin though?
From a specific point
Okay, so it's where you are
in relation.
in relation to where you began. Okay, so this is saying that we are 920 feet to the left, if it's moving left or right, if it's negative, okay? I'm 920 feet left of where I began. Okay, so part B says your answer to A is actually the displacement rather than the distance traveled. Why? Well, we will get to that shortly. Give the position of the car at t is equal to 60 if the initial position was at 200 feet. Okay, so what you need to know for now is that position is going to be the initial value plus the displacement. Okay, and so my initial value, they tell me we start at 200, and then my displacement was -920. So my final position is going to be -720 feet. And that is Riemann sums.